Hello everyone, in this video we are going to continue the conversation on graphing systems of equations and determining their solution. In the previous video we talked about how we have three different kinds of solutions. We can either have a no solution, a one solution, or infinitely many. And we talked about what would be the key pieces to identify those solutions. So let's go ahead and start graphing some of these out. Now, some of your equations are going to be given to you either already ready to graph in slope-intercept form, but if they are not in slope-intercept form, then I'm going to ask you to solve it for y so you can identify the slope and the y-intercept and graph them on the coordinate plane. So as you can tell on our first example here, I'm going to go ahead and call this y1 because it's already solved for y. We can see that our y-intercept is a positive 2 and our slope is going to be negative 4 over 3. Now remember, when you're doing your slope, it is in your best interest to write it two ways. So I'm also going to write a positive 4 over negative 3 just in case we need it. All right, so this one's ready to graph. Let's go ahead and graph it out. Find your y-intercept, then go down 4 and to the right 3. And if you run out of room, then go up 4 and to the left 3. All right, so if you used the same slope and the same y-intercept, you should have this line on your paper. Notice that I labeled it number 1. I'll come back and do all the color coding later. Let's go ahead and talk about the second equation. This one is not ready for us to graph because it is in standard form. So I am going to ask you to put a 1 here as a placeholder so we can then subtract 1x. So we're going to subtract 1x from both sides. That's going to give us 3y is equal to negative 3 minus 1x. From here, we're going to divide by 3. Please don't forget to simplify your fractions and to pay attention to those negatives. So this becomes y is equal to negative 1. And since we cannot reduce a negative 1 over 3, let's just leave it as a minus 1/3 x. All right, from here, we know our y-intercept is negative 1. Our slope is negative 1 over 3. And then the opposite slope would be 1 over negative 3. So that way we can create both sides of the line. So this is going to be our y2. So now that y is by itself, we can say that this is y2. And then we can label that line y2. So we're going to start at negative 1 on the y-axis. Then from there, we're going to go down 1 and to the right 3. And then we're going to do the reverse and go up 1 and to the left 3. So let's go ahead and graph that out. All right, so as you can see, I went ahead and graphed line number 2. Here's my y-intercept. I went down 1 and over 3. And the first time I went down 1 and over 3, I realized that that was a point on our original line, line 1. So I went ahead and circled it and then kept on going down 1 and over 3 in both directions. So now that I have both of my lines, I could see that they do intersect and I can see where they intersect. So it's not enough to just graph it out. We do have to identify that point. And I'm going to remind you that when you identify the point, you have to write it as x comma y. X comes first and then the y, because sometimes we like to get those numbers reversed. So this point on the x-axis would be 3, positive 3. And then the y-axis would be negative 2. So make sure you're looking at your x and then your y. All right, so I'm going to go ahead and color code this, and then we're going to move on to the second line. All right, so let's go ahead and look at the second line here. So one of the things that we're going to notice is that they are not ready for us to graph. They are in standard form. We have to solve both of these equations for y. Now, before you do that, I do want to point something out. If you look at the left side of both of these equations, you're going to notice that they are exactly the same. And then on the other side of the equal sign, you're going to see the positive 2 does not match up with the negative 6. So there's something special about the left side when it's written in standard form being the same. That's all I'm going to say. And then we're going to go ahead and solve that out and see if it can prove what you're thinking is going to happen. So let's take the first one, the top one, and let's solve that one for y. So I basically just rewrote it underneath it just because I need the space to actually work it out. So let's go ahead and subtract 3x from both sides. Don't forget to carry the x, and do not forget to bring down the negative with the 2. So we have this negative 2y is equal to 2 minus 3x. Let's divide everything here by negative 2. And so we get y is equal to negative 1. The two negatives become positive 3 over 2. Okay. So from here we know that our y-intercept is negative 1. Our slope is 3 over 2. But we can also use negative 3 over negative 2 to help us graph that line in reverse. All right, I'm going to take this one right here and I'm going to rewrite it so we can then solve it and do the exact same thing. Okay, so from here we're going to subtract 3x. Bring down the negative 2y is equal to negative 6 minus 3x, and then divide by negative 2. Okay, I don't have any room here, so I'm just going to kind of write it over here on the side, like right here. So I'm going to say y is equal to positive 3 and a positive 3 over 2x. So I can say that my slope, my y-intercept is 3. My slope is 3 over 2. And the opposite slope is negative 3 over negative 2. So I want you to take a moment. I know we did that kind of quickly. But I want you to take a moment to identify. There's a lot of work here. So find our y-intercepts, our equations that we're going to use to graph. So here is one of them. Sometimes when we have a lot of work, it's easy for it to get lost in our work. So I need to go back and kind of point it out. If you don't want to use highlighters, remember, all you have to do is circle it, put a box around it. All right, so if you're going to compare both of these lines, we've already identified the y-intercepts, and one is negative 1 and one is positive 3. But you're also going to compare their slopes. And hopefully you can see that the slope of the first line, 3 over 2, is the slope of the second line, which is 3 over 2. So from here it tells us these two lines are parallel. So that tells us that our solution to the system is a no solution because they will not intersect. We still have to graph them because we still have to provide the visual that these lines are parallel. But now you have the proof right here that they are. And even when we zoom out or look further past, they're not going to intersect anywhere in on the coordinate plane. So let's go ahead and graph these out, color code them, and then write out our answer. All right, so for this one, I went ahead and color coded, named one of my equations y1, the other one y2, labeled them and color coded them. So you can just do one or the other. You don't have to do both. But I also came to the top up here to tell you that we do have to write it in. We have to show it on the graph, but we need to also write in no solution. All right, so let's look at the last one here. Notice that this one is not in any particular order, but the thing that does stand out to us on these two equations is that the y is not by itself. So in order for us to be able to graph something, the y has to be by itself so we can pull out the slope and the y-intercept. So if we're looking at the first one right here, notice that we have to get rid of this negative 4. The x is already on the other side, but we still need to get rid of the negative 4. And then we also need to get rid of that negative 4 so the y can be by itself. So I'm going to go ahead and rewrite it, and then let's go ahead and solve it. All right, so as you can tell, I rewrote my equation here. I also gave the x a placeholder 1, just because I need you to know it's there. And then from here, we're going to add 4 to both sides. And so when you bring this down, please don't forget that that 4 right there is a negative. So we're going to bring it down as a negative 4y is equal to negative 1x plus 4. Then from here, we just need to divide not by 4, but by negative 4. So don't forget to carry over the negative. So we have y is equal to a positive 1 over 4x and this right here becomes -1. So we can say that our y-intercept is -1, and one of our slopes is 1/4, and the other slope is -1/-4. So I'm just changing both signs so we can graph this in reverse. So we're going to call this y1. And before I graph it out, I'm just going to go ahead and jump into the second one. So let's go ahead and take this one, let's write it down here, and then let's solve it, just because it's not in the traditional standard form that we're used to. So I just want to make sure that we know how to solve something like this correctly. All right, so as you can see, I took this one and just rewrote it down here. And the reason I want to talk to you guys about this one is because sometimes when we see that 0, we don't know what to do with that 0. And I'm just going to remind you what I've told you about the 0 before. It's just a placeholder, so that way this side of the equation isn't just completely blank. So once we move one thing over, that 0 is going to go away. So don't stress about the 0. So our ultimate goal is for the y to be by itself. And right now we need to get rid of this 4 and this -x because they're not attached. So it doesn't matter which one we do first, but we do need to get rid of both of them. And then we'll get rid of the 4 that's attached to the y. So if it's okay with y'all, let's go ahead and do one at a time. Let's do -4, -4. So that leaves us with 4y minus 1x. I'm going to go ahead and put the placeholder 1 is equal to -4. Because if you were to do the math here, 0 minus 4 is just going to give you a -4. Or, since the 0 is a placeholder, it just goes away when you move over the -4. Same thing. All right, from here we need to get rid of the x. It's a -1x, so let's make it a +1x over to the side. We have 4y is equal to -4 plus 1x. And now it's starting to look like something we already know. So from here, let's just divide from 4. It is a +4, so we'll divide all of these numbers by +4. And this gives us y equals -1. There's nothing we can do here, so we'll just leave it as a +1/4. And since we solved this for y, we're going to go ahead and call it y2, because this is our second line. And I'm just going to write it up here. We're going to say our slope is equal to -1. Our y-intercept is -1. Our slope is 1/4. The reverse slope would be -1/-4. So I'm going to give you guys a chance to go ahead and graph not only line 1, but line 2. Hopefully you can see some similarities, but go ahead and graph it out and see if you can point them out. All right, so I took the y-intercept and the slope to graph this line. So notice here's my -1 on the y-axis. I went up 1 and over 4. And then in reverse, I went down 1 and over to the left 4. And it created this line. So we can say that this is line 1. When you go to line 2, if you haven't noticed already, you can see that it does have the same y-intercept at -1. And it does have the same slope. So with that being said, we know that these lines are exactly the same, one on top of the other. So if I were to graph all these points, they're already graphed. So I'm just going to circle them to represent that these are all the same. And so this is not only line 1, but it's also line 2. So I'm going to go through here and color code it. I'm just going to color one side green and the other one blue, and then do the same thing with my equations to show that they are the exact same line and they have infinitely many solutions. I hope these examples have helped you feel a little bit better about how to classify and identify the different solutions for systems of equations. We still have another set that we need to look at, so I'll see you guys in the next video.